Okay, so let's talk about snow. And for snow, we will have this kind of chunk features. Small pieces glue together, and when they hit the surface or ground something, they may disintegrate it into small pieces. So we can see there's a big chunk here, and it's smashed to the ground and disintegrated into tiny pieces. Yeah, the resolution for this simulation is really low, so we can see this stirring effect. Okay, because when I'm rendering this, I'm using a volume, and it turns out the resolution is just being too low. But what I wanted to talk about is how to set up this in Vellum Grand, and it will be an easy setup. So first we have to understand Vellum Grand, and let's drop a box and use Vellum constraint Grand. So basically we are just creating some particles with some attributes, the p-scale, which is the radius of the grain size, and some sprite. So we have this circle material. And we can simply use the Vellum solver and just input the object, Vellum object, initial geometry to be this guy, and let's run the Vellum solver. Basically, it's just particle simulation, like the pop network. Okay, but this is Vellum, so each particle has a radius and they will not collide. They will not intersect with each other. And we can create constraint between each particles. Just like RBD simulation, we usually have to prepare some constraint geometry. So we can use connect adjacent pieces or whatever method. And here I just, so this will be the simulation geometry. And this will be the constraint. Here I use the Vellum distance along edge constraint. So let's put them into the Vellum solver. For the first input will be the geometry, the second will be the constraint. So let's see the simulation again. So we can see all the particles are being held together because they are being held by the constraint. And there are different types of constraints like Vellum glue constraints. Here just lots of constraint. And for different type of constraint, Vellum might set up different geometry. Like this is the distance constraint, and some constraint could be breaking. So when, say, the stress is above a threshold, the constraint can be broken. So we could create for this kind of snow simulation, we can create many small pieces cluster, and there are some constraints inside the cluster. Just look like this. Wait a second. Like this. So we have, this is the snow, we have this kind of constraint here, here, so they are being held together. And another thing to learn is the attraction force, attraction weight. So I use a points wrangle here to set the point attributes, attraction weight here. Because in fact, Vellum solver is just the particle simulation. So we could use, let's go to the Vellum solver, then the advanced tab. For grains collisions, there is a setting here which is attraction weight, and it's a weighting for how much the particle will naturally stick together when close. So let's set this value to be 1. So basically, if we set the point attribute attraction weight, and with this setting on, each particle will try to attract to each other. So let's set this to, first let's set this to 0, and we will see the particles will disintegrate. But let's set this to be 1. We can see now every one of the particles are being trying to attract to each other. So we could also use this point attribute and maybe set the attribute differently on different particles, so we can also create some kind of chunk effect. Yeah, so for the snow simulation, again, we can set the attraction weight maybe by a noise. So for each of the particle, the color here is the attraction weight by using some noise. And yeah, so this will be the simulation result. We have lots of particles. Yeah, we could see we have some kind of small chunk here and there. It's hard to see here because we have so many particles. Yeah, and also for the Vellum simulation, we could also use the pop wrangle, basically the point wrangle in the darknet, and to set the point attribute stopped. So let's set the attraction weight to be 0, and let's disable this first. And as expected, all the particles just crashed. And if we set the stop to be 1 and enable this, and yeah, running on the geometry, we see that the particles are being stopped. Basically, they are not being simulated by Vellum. So this attribute is kind of like the active attribute in RBD simulation. In RBD, we have packed geometry, and we will set active to 1 or 0 to enable the pieces to be simulated or not. And in Vellum, we have pop network, so we use stopped. And another way to achieve the same result would be to set the mass to be 0. So we have the same result. Let's set the mass to be 1. You can see. Yeah, so for this kind of snow simulation, we can see that all the particles here and they are being stopped, and the middle are being enabled. And we can just use attribute transfer to transfer the enabled particles to the non-enabled particles each frame. It's kind of like a disease growing. So in the darknet, we could use a post solve, we could use a subsolver, or any kind of thing you like, and to transfer the active attribute, the stop attribute, like this, like a disease. Yeah. So it's just a really simple setup. Yes.